Okay, so for the friction lab, what you're going to do is watch a video for the data collection. In your analysis, you're going to make a graph and a data table. Each person should be able to do this on their own. However, you are allowed to work in groups of no more than 4 total people. Afterwards, once you get the data, you're going to use either Excel or Google Sheets to determine the equation for the graph. Finally, you will use the data to determine the coefficient between a block and a table. Now, right now this link is currently inactive because I'm recording this video right now, but these will be the notes that's going into here. This is a video of the trials, and then this is where you submit the lab. I'm going to add another link here that shows you how to make the graph and have the graph display the equation in Google Sheets, so you don't have excuses for why it wouldn't be done. Now, the video of the trials is right here. It is a very boring video, but it does serve its purpose by, outlining what's happening in the lab. You have a block here of a known mass, which you're going to see in a second. You take that block, and this block was put on the scale, and it reads a mass of 392 grams. You'll need to convert those grams into kilograms. To do so, you divide by 1,000. Afterwards, a spring scale is attached to the block on the hook, and it pulls on the block and records the force in newtons. We also have 100-gram masses that are placed on top of the block, and as those 100-gram masses are placed on top of the block, this is just me mounting my phone for the setup. The 100-gram mass is placed on top of the block, and then through the hook at the end, the spring scale is attached. Remember, you need to include the mass of the block as well as the mass added and convert it to kilograms. Afterwards, the spring scale is attached and it is pulled, and you are recording right until the block begins to move and you see how much force was required. It's going to go through 9 more trials after this, which you are free to check out on your own. You'll have 10 data points total. You'll submit the lab here. When you go to submit the lab, you will see the group member name, that's yours, and then you can have up to 3 other group members. You select the hour that you're in, and there's only 2 things you need to do. You need to upload the data table and the graph. The coefficient of static friction is what you're going to determine, and the rest of this video is going to show you how you would determine that. So essentially what you have is you're using the friction formula, which says force of friction equals the coefficient times the normal force. The normal force, since this is conducted on a flat table, the normal force is mg. Remember, you must convert, so must convert the mass in grams to kilograms. To do that is very simple. Let's say you had the 392 grams from the block itself plus 100 grams from the mass cells added on top. You get 492 grams. 492 divide by 1,000, and I'll get 0.492 kilograms. That's the conversion right there. In the video, you will see that the spring scale pulled on the block. The force, the maximum force that could be exerted before the block began to move, that is the force of friction. So as you're going to make your graph, you'll be able to say, okay, I have friction on the y-axis as my dependent variable, and I have mass on the x-axis as my independent variable. And the force of friction equals mu times m times g. The masses, that was I was showing you the conversion here. That's what you plot on the x-axis. The force of friction on the y-axis. Again, there is a video of how to do all of this. So no excuses as to why you can't. You'll get a scatter plot with a best fit line, and the slope is going to come out to a number. Let's say, for the sake of argument, your slope comes out to 7. Now, your goal, the ultimate goal, if we come back here, is what's the coefficient of static friction? You need to figure that out. If Excel or Google Sheets told you the slope of your line is 7, you take a look at what is written here. Force of friction equals mu mg. Let's cross out all the variables that we already have in place. We have the force of friction, which is our dependent variable, so goodbye to force of friction. We have mass, which is our independent variable, so goodbye to mass. And then what's left over? Mu and g. Mu g is the slope. This equation was taking the form of y equals mx plus b. There was no y-intercept. Without any mass, there will be no friction. The x value is mass. The y value is friction. So what I have left over is m, or slope, and that's mu g. So mu g is the slope. At this point, I would take 7, and I would set it equal to mu g. Since this is in a lab, you're going to want to use 9.81 instead of 10. But then you would solve the coefficient in your calculator. You take it, you punch it in here, you click submit. It will go ahead and send you an email saying, hey, look, you've gone ahead and submitted this. Congratulations. Enjoy.